All right, so again, say if you can understand this, you'll probably earn a point or get a question around the SAT or the PSAT. So the properties of logarithms, the first thing that we'll want to be able to do is we want to be able to look at our calculator and know what to do with logarithms. Okay, so your calculator has two log buttons. Okay, and Ben, this is where your mistake comes in here. Okay, your calculator has a log button. Is there a base there?
No, sir.
No. That is base 10.
Base 10.
Okay, the base is not showing, but if you see log, and then if I put 100, that is log base 10, 100. Okay? That's a fantastic question. Okay, so log 100 is log base 10, 100. That's calculator talk. And this, if you see this, it's going to be in math books like this. You just assume it's base 10. Okay? All right? We'll get to changing base here in a sec. All right. The other is ln. Okay? That is not base 2. It's base E. Okay? So what's the answer to that going to be? If we have log base E, E squared, what do the E and the E do with the log? They cancel, so what's the answer? 2. Okay, so the other thing on your calculator is ln. We can just put, okay, that is the same as saying log base E. Okay?
Wow, what that was good.
Those are the only two log buttons you have. Okay? So different bases. There are two ways to deal with this. Okay? Number one, in the math menu, I think on these newer calculators they actually give you a log change of base somewhere.
Yes.
Log base. It's under math, log base, and you can put the base in. Should have deleted this. So if I say, what's log 7, 49? Answer? 2. Pick that up. Jerk. Thank you. Okay, so that's 2, correct? Okay, so one way to deal with different bases is math menu, down to log base function, okay? You good with us?
Yes.
Okay, here's the other way to deal with it. That's an eraser. Fantastic. Okay. Change of base formula. Okay, so if I give you, without a calculator, log 7 of 200. Okay, and you this is not going to be this would have to be calculator friendly. Okay, how do I write that without a log base 7? So let's say when we want to write a log base 10.
I got you.
Okay, it's log 200 over log 7. What base is that? Base 10. So if you type that in your calculator, or you can use the math menu and type that and you'll get the same answer. Okay? So that's called the change of base formula.
Do you have to put, you don't have to put that in the calculator?
Yeah, you can't solve this without a calculator, but most of your calculators are going to have this function in them. Okay, but knowing that you are on the PSAT are not going to get these fancy calculators most likely, you might have to use that. Okay? Scientific calculator will have log and natural log on it, but it will not have this function in it. Okay? So that's why I show you. Most calculators do not have this in it. Ours do. Okay, so that is like a summary of calculator logarithms. Right? You good with that? Okay, moving on. Okay, properties. Let's do a little compare contrast here. Because you know these, right? Properties of powers? Okay, let's relate them to properties of logs. Okay, what do you do if you have that? Yeah. You plus it without being more specific in our language.
Add.
Okay.
Loser.
I'm a loser, yeah.
Yeah.
Okay, there's a very similar property of logs. Okay. Log A. Right. Very similar, right? They're multiplied?
Yeah.
What are you going to do?
Divide.
Split and add.
Is that times m?
Yeah, n times m. They're multiplied here. That means you can split and add. Okay. Little different than the log property exponents, right?
Can it go the opposite way too?
Yeah, if you're given this, you can go backwards. Yeah. Okay. Let's see. You're killing me, Micah.
Why?
That burrito.
Smells good,
Yep. Okay, I'll show you examples of these here in a bit. Okay, what do we do here?
You subtract.
Uh-huh. So if I had a log, division, it's exactly what you're thinking and saying. Okay. See how divide, subtract, divide, subtract. They go together, right? Okay. What if I have this in an equation? What do we know about n and m? No, n and m. It's not candy time. You don't want to rot your teeth before you're 20. So if the bases are the same, and these are equivalent, what do we know about n and m? Yeah. Correct? Pretty basic. Logs have the same property. Bases have to match. You guys know what that arrow means? Equal sign with arrow, it means implies. It means that tells you that. Okay, a little bit of math notation for you. All right. All right, there's one more. Okay, if I have a log base a, b to an exponent, okay, this is the one that kind of messes with people because you haven't seen it before or anything like it. If I have an exponent in a log, I can bring it out front. Yeah, your face. What the heck just happened? Yeah, that just happened.
Crazy. What just happened is that just happened.
Do you have
Okay.
to do anything to be able to move that from?
Here's where we're going to use this no calculator style. Okay, so let's say I have log 749. You know the answer to that. 2, right? Yeah, okay, but how do you get there and show that's true? Log 7, and this is 7 squared, right? Now that 2 is an exponent here, we can bring it in front. That's 1. Okay, there's one use of that right there.
Well, I think. Wait a minute. What?
2 times 1 is 2.
No, what's the line above that? What is log 7?
2 log 7, 7.
Oh, snap, that works!
All I've done is take the exponent out front.
You're crazy.
Me?
Come up with
Oh, you have no idea.
Dude.
floor months.
Dude.
Do it.
Dude.
Dude.
Do something cool.
Do something cool.
Happening, guys. Dude.
Most of the things I do by myself are cool, but I'm by myself, so nobody ever sees it.
Tell me about it. Yo.
Okay, those are the properties of logs.
I can tell you another property of a log.
Is there a
Logs roll downstairs,
No
one's here to see this.
run over your neighbor's dog, fits on your back, looks great as a hat. Log, log, log. He has no idea what I'm talking about.
I don't know.
You uncultured swine, he knows.
Dude. Yeah. It just says
He's, you're at the Ren and Stimpy level, aren't you? There was a really stupid cartoon when I was your age they called Ren and Stimpy.
Oh. There's a really good cartoon.
Yeah. That is like exponentially more intellectually stimulating than Ren and Stimpy. Pinky, tonight we're going to take over the world. Yes. It is on the level of like Beavis and Butthead. You ever heard of that?
Beavis Butthead.
Well, that too. We have fine examples of those. Okay.
Oh, wow.
The thin one, the super thin one.
Let's use these.
That.
Solve.
Better terminology.
Log. Base P. We're going to solve for the base here. Okay? 64 to the 1/3 equals a half.
So you can put the 1/3 in front, right?
You could.
What is that number?
Sometimes, so when you're analyzing logarithmic equations, my first thought is always to put it in an exponential. My second thought is to use properties. Okay, because we could move the 1/3 out front, right? But where would we go after that?
64.
Okay, if that's what you want to do.
Is that what you would do?
We can do this. It's not my first thought, but it's going to work. What would you do next? You divide by 1/3 or multiply by a 3, right? Right, so we get log P 64 equals 3/2. I'm good. How would you solve that?
Exponential.
Okay. What is the exponential?
64.
P 3/2 equals 160.
You sure? You should be.
Is that right?
Okay, how do I solve that? We did this last week. Exponent to the 2/3, right? Because 3/2 of the 2/3 is 1. Correct? All right, so what's 64 cube root?
4.
Squared.
8. 63.
Thank you for the correction. Okay, remember, big number, do the root first, square second. Okay. Okay, that's one way of dealing with this, right? Mess with it, turn it to an exponential, get her done. You could, right now, turn it to an exponential.
Wait, how do you
P4 equals 1.
How do I know
64?
64 to the 2/3? So you cube root 64, which is 4. 4 squared. 16.
Right back here.
You could also do this.
What?
Whoa, a little intense in here. This ends up following a very similar process to what we just did. It just puts it in an exponential all really quickly. You want me to solve that? Or do you want to you solve that? Okay. What's 64 to the 1/3?
4.
It's 4.
Yes.
That's cube root of 64. So p to the 1/2 equals 4.
P is 4 squared.
Square both sides, because that's a root, right?
Oh, they're the same thing, man.
Yeah, which one was easier?
That one.
Which one's that one?
The right.
The one on the right? The
The
one on the right's easier? Are you serious?
The second one on that one. The second
The one on that one.
Write it down.
You guys need to, like, specify language here.
The one on the right side is the light.
Is this the one to Emmett's right?
The one to my right.
Okay.
The one is
Okay, that would be more specific. Okay.
The one left to Kentucky.
One more. One to the left of Kentucky. That would be both of them.
Exactly. 49. That would be 2 1 That's 7, right?
Okay, here's an equation with logs in it.
Takes 2 of these. Yes, sir.
you want to call that?
Calculator
Sorry.
Oh, yeah.
X
Okay,
is 1.
so as of now, can I turn this into an exponential?
Yes.
Wow, that was a contrast in answers.
You were shaking your head no before you even said it. No, you cannot.
I was not shaking my head
Yeah.
to imply the answer was no.
No.
I might have been shaking my head.
No, you cannot.
There's a plus sign here.
Exactly.
I cannot exponential this yet.
Loser.
But what can I do with these two?
What are
Do they have the same base?
No. Put 'em together.
Yeah.
No.
So we're going to use that property right there. See, they're added, same base. We're going to put them together and multiply. Okay? So, log 11 x times x plus 1 equals log 11 6.
Oh, that's it. That's a +1. I thought that was X.
Yeah, I like to put two variables in equations. Not really.
Just for you.
Okay, what can I do at this point?
Do the same thing. You sound like a
Kellen, quit guessing.
Can you put that extra +1 in front of the log?
No, this is not an exponent. We can't move them. Okay,
a little bit extra.
Brandon. Okay, we're getting a little out of hand here. We're almost done. What does that property tell me? The logs are the same base? Then these are the same, right? Okay, so if I use that property,
You can make it equal 6.
what am I going to write?
Log 11 6.
X.
Times x plus 1 equals x. Equals, yeah, that's what it says.
Right, these are the same, which means that these are the same. Okay, now you just have,
1x equals 6.
stop thinking, next step, and you solve a quadratic.
Oh my
No.
Subtract 6.
I'm wrong.
What do you always do with a quadratic?
God. Set it equal to 0. Now solve it. 2 and 3.
No,
Wait, plus 3.
wrong.
Plus 3 minus 3.
I was just saying your previous proofs that was the same. I was saying
Whatever.
2 and 3 is what you plug in.
2 and 3. No, negative 2, 3 and 2 are the answers.
Wait,
No,
why
it's
did you
negative
get
3 and positive 2.
Okay.
Not
Negative 3 and 2. That's what I said.
Here, just look at it.
I have a feeling you want to square up.
Okay, so we know that
Let's go.
people
You have to plug in and check.
Oh, my arms are longer, not a square.
Are they?
Yeah.
this number always going to be how much
Okay, there you go. There are your answers.
P, right? Just for each people times P.
Do they both work?
1/2. Yeah. Put that equals 64.
So if I put that in for x,
That'll work.
log base 11, negative 3. What's the domain of log function? Or positive x's. Can I put a negative in here? I cannot.
Put it over 1.
Not a solution.
So the only solution is
Okay? You always have to check your answers. Okay? Log domain is the positive real numbers. Okay. I'm done dealing with your lunacy. Do you have any questions?
A lot of it.
Make me jump off a cliff. I'm pretty sure I don't have the guts to do that. So. Okay.
Well,
No, this parentheses here, not here. So you just take this and move that front.
77 to 105.
what is that?
Number 77 equals 105. Oh, shut up.
I was just asking.
I don't think so.
77 has a degrees, minutes, seconds problem. That's the decimal of it.
Boom!
I need help.
Yeah, you do.
I do.